Well, let's go ahead and talk about the periodic table and what the periodic table is. Well, here is a picture of the periodic table of elements. And as you can see, there are 118, and here's number 118 over here in the far right-hand corner. Okay? And about 90 to 92 of these elements are found in nature, just naturally occurring. The rest are created in laboratories. But let's just give a brief overview of how the periodic table is laid out. We have rows that run left to right. These are called periods. Thus the name periodic table. Periods. Okay? And the reason they're called periods is that as you go left to right across the period, patterns repeat. And there's periodic properties. For example, everything that is in this group, every eighth element occurs in this group. And so these columns that run down are actually called groups or families. Groups or families. And as you can see here in this periodic table, there is a nice little legend right here telling you what all the symbols are. And in the top left hand, now sometimes this occurs right here in the middle, this number. For this one, it's number 6. Sometimes you'll see it in the middle, like written right here. That's called the atomic number, and that represents the number of protons. Represents the number of protons in an element. So if you're looking here, carbon has 6 protons. Then there's the chemical symbol right here, chemical symbol. For carbon, it is C. This is either a 1 or 2 letter symbol. Now some of these have 3, like right here, UUT, UUP, UUS, and UUO. Those are elements that have not been created in laboratories as of yet, and so right now they give them UUT, which stands for 113 in Latin. In addition to that information, the atomic number and chemical symbol, there's also the name, which is written in each box. So over here we have hydrogen, okay, and then we have lithium right underneath it, followed by sodium and potassium. And you'll see that some of the letters of the chemical symbol don't really match the names. That is because those letters, for example, Na for sodium, there's no N or A in the word sodium, but Na comes from its Latin name, which is called natrium. Or over here, for example, Pb for lead. Pb for lead. That is for plumbum, which is its Latin name for lead. And the last piece of information here is the atomic weight or atomic mass. And this is essentially the average mass of all isotopes. That's an O, isotopes in an atom. And we're going to discuss in the next video what an isotope is. But there's just a brief overview of the periodic table, how it's laid out. A couple of other features of the periodic table. This one specifically tells you whether or not the element is a solid, liquid, or gas. This one indicates that element right there. Nitrogen is a gas with the cloud. The brick right here, or the cube, indicates a solid. And there's actually only 2 liquids on the periodic table. The 2 liquids are bromine and mercury, Hg, which is right here, number 80. Those are the only 2 liquids, and we're talking at room temperature that they're liquids. Same thing with the gases. At room temperature, they're gases versus the solids. Most of the elements on the periodic table are solids, but there are, like I said, a few that are gases and only 2 that are liquids. You'll notice that all the gases are on this side of the periodic table, the right-hand side. This is where the nonmetals occur, okay? Versus on the left-hand side of the periodic table, Over here, you're going to see these are where the metals occur. They occur on the left. And there's this black, dark black line, and I'll just highlight it here in red, that goes like this on most periodic tables. The stair-step line here separates the metals from the non-metals, and all of these elements that are along this line right in here, okay, all these elements that are right in here, those are called metalloids. They have properties of both metals and non-metals. So there's just a brief overview of the periodic table. There's a lot more that goes in to that, but we're going to use that information to help us determine how to determine how many protons, neutrons, and electrons are in each element, as well as determine the different amount of neutrons in the isotopes and different number of electrons in the next video.